Hi everyone, welcome to AI Masterclass. In this video, we'll cover what are LLMs, we'll create a hello world application for LLMs, then we'll look into what are LLM tokens, then we'll explore what are embeddings, then we'll look into VectorDBs and building RAG applications. After that, we'll look into model context protocol, which has been very popular these days. And after that, we'll look into Agentic AI. I think Agentic AI is one of the most favorite topic of everyone. So we'll look into that. In addition to the topics mentioned earlier, we'll also discuss context window, adding memory for LLMs. We'll also set up our environment so that we can practice what we're learning. Then we'll talk about different agentic frameworks and build some applications on that. Then we'll focus on how to fine tune our LLM. We'll take an open source LLM. We will fine tune that LLM for one of our use cases. So let us start our masterclass. So in this video, we will learn about what is a LLM and how do LLM work and different use cases of LLM. So what is a LLM? So in simple words, LLM is a very smart next word predictor. Now you will ask me that there are already autocompletes and next word predictors existing. Why is LLM special? LLM is special because of two things. One is it uses neural network to predict next word, and it's trained on huge amount of data, billions and billions of parameters, and those neural networks use a new architecture called transformer architecture, which makes it far more better than existing neural network implementations. Let us go in slight detail. Suppose there is a user which sends an input to large language model. Input is a phrase, once upon a time. So when this is given as an input to LLM responds back with the most probable word. In this case, it is there. Once upon a time, there. Then that phrase is given as an input, and it again responds back with next word. Once upon a time, there was, and so on and so forth. And that's how it completes the sentence or the story that you have asked it to complete. So this is what, in simple words, a large language model is doing. It's just predicting the next word. However, as a user, you get an illusion the whole sentence or the paragraph was created, and there is just fast typing. Let us see what are the different types of large language models we have. So most famous one is OpenAI's ChatGPT, and then Anthropic's Claude, and then Google's Gemini, Mistral AI, this is a company from France, and then Grok, and then DeepSeek from China. These are called frontier models. They are state-of-the-art models trained on billions and billions of parameters, and they are very accurate and give you very high quality of results. Then there are a class of models which are open source. Llama is by Meta. It may not be as accurate as the foundation models or the paid models that you see, but it's free. This enables a lot of developers to use it and improve it and build applications on top of it for free. Then there is Gemma by Google, and then there is Qwen by Microsoft, DBRX from Databricks, and Falcon. Falcon is a model which is created by UAE government, and it is also considered to be fairly popular. There are also specialized models like FinGPT, which focuses on financial domain. Then there is BioGPT, which is expert in biology related topics. Then there are models which are focusing on law as a domain. And then we have Code Llama, which is built by Meta and specializes in coding related tasks. As we talk, large language models and generative AI is being used in a lot of domains, especially the customer support robot. Generative AI is also being used a lot in media domain to summarize document, to create new content, to make more relevant content. A lot of companies like Meta and Microsoft and Google are claiming that around 30% of their code is being written by AI, which is huge. So as we speak, AI is being used in a lot of spaces. That makes it more important for you to learn and build your skills on generative AI so that you are more relevant in the job market and you can build really good products. So I'm very excited to show our first AI application, our Hello World program, and show you that how easy it is to build AI applications these days. So this is my GitHub page. All the code related to this course is available on GitHub. Don't worry about the setup in starting. There is a separate video which you can watch to complete the setup. Just focus on learning and understanding the core concepts. So we will be using Google Colab for all our learning. You can click here. It will open a Google Colab notebook. You can run your code in that notebook and learn. As simple as that. Let us first connect it with the runtime. You can click on this connect button. It is showing connecting, may take few seconds. This is ready. So here I have got a OpenAI key and I'm installing OpenAI related libraries. This is done. Now I am importing OpenAI library, done. I have initiated a client so that I can call ChatGPT API. Now this is my prompt. I have written a story, but it's a incomplete story. We would like ChatGPT to complete our story. So now this is very important. So we are going to send a message to OpenAI ChatGPT model, and that message should have a structure. This is the standard format which was created first by OpenAI, and it has become so popular that all other companies have started to follow it. Like Google, Meta, everybody follows the same format. So it is very important to learn this format because this is a standard across. If you're building agentic AI solutions, if you're calling Claude, if you're calling Gemini, this format is the standard. So spend some time on it and understand it properly. Message is a dictionary. It should have two things. One is system message, other is user message. So to give the system message, you need to define role as system and say content of system messages this. And then user, you need to say role is user and this is the prompt. Let us understand what is this system prompt and user prompt. System prompt gives LLM a persona. So if you want your AI to behave as a doctor, you tell it that consider you are a doctor and answer my questions considering you are a doctor. Or you can say you are a comedian and answer my questions being a comedian. The kind of answers and the quality of answers will depend on what is the persona that you are giving to your AI. So that's why system prompt is very important. And user prompt is the query or the message that you are sending to your LLM. Let us run it. Okay, so these are the APIs, client APIs, client.chat.completions. If you're finding it a bit clumsy, don't worry, you will get it very easily. With more practice, you'll get completely familiar with this API. So we are calling the chat completion API. We are calling the model GPT-4o mini. We have passed the messages object, the dictionary which we created in the last cell. And then we are giving the temperature 0.7. Let us understand what is temperature. So temperature controls the creativity level of your LLM. What does that mean? So if it is 0, you will get the same answer every time you call your model. If the temperature value is greater than 0 and less than 1, then the answer is usually similar, but there may be some creativity. But if the temperature value is more than 1, there is more randomness in your answer. So whenever you ask ChatGPT, it may give very different answer every time. So as an engineer, you can play with this value and see based on your use case what kind of response you want. If you want same response every time, make the temperature as 0. Let us run it. So this is the response which I have got. Now let us play with system prompt to understand how important it is. I'm going to say you are a comedian, answer everything with a joke. So when I run this, I get a joke in response. So based on the persona that you are giving to your AI model, you'll get the kind of answers. If you are asking it to become a doctor, it will answer it in that way. If you are asking it to become a dumb guy, it will answer in that way. So that's why the system prompt is very important. So this is our Hello World program. You just need to create a message object which has system prompt and user prompt. You need to tell which model you want to access, give it the messages object and set the temperature. That's all. You're ready to get responses from LLM. Do you know ChatGPT charges you for the punctuation in your messages? And this is because of token-based billing model that they have. And that's amazing for business. Let us start by understanding what is token. Most people think if they're sending an input text to ChatGPT, then every word in input is a token. And that is wrong. First of all, words are not tokens. Then what is token? Let us take an example. Here, understanding is made of 3 words: under, stand, and ing. LLMs treat all of these subwords as tokens. So understanding will be mapped to 3 tokens, one for under, one for stand, and one for ing. But why do we need tokens? Why can't words directly be used by LLMs? Let us understand this with an example. Suppose we have 3 words: player, played, and playing. When these are given as input to ChatGPT, it converts it into base words. So this makes it easier for ChatGPT to find out that these words are related and easy for it to find a relationship with other words in the sentence. This reduces the need for memory and processing power and makes the algorithm more efficient. Let's take another example. Each word is converted into 1 or more tokens. So if you notice here, exclamation mark is converted into a token and amazing is broken into 2 tokens. But should it matter to you you? Yes. So depending on how complicated words you use or how much punctuation you are using in your messages, you'll be billed. Now let us explore LLM tokens a bit more. This is my GitHub page. Link is in the description. You can click on this notebook and it will take you to this page. Let us connect to the runtime first. My runtime has started. Let me clear all the output. Awesome. Let us first install transformers. This is the library which will have the tokenizer. So that's why we want to install it. Now we will import auto tokenizer from transformers library till it runs. We will use BERT-based uncased model for tokenizing our input data. There are many models which are available. You can check it and you can change the model. ChatGPT uses something called tick token as the model. There are many other models available on Hugging Face. You can also use that. It has run. So let us continue with this. Awesome. This has downloaded the token. Now this is our text example. This is another text example. I have created this function where I'm getting this as input text and I'm tokenizing it. Then I'm printing the input text which we have got. I'm printing the tokens that we have got, and I'm also printing the number of tokens we have got. Let us pass our input text to this function. Awesome. This is the output we have got. First sentence was tokenization is fundamental for large language models. It has split into these many tokens. Tokenization is fundamental for large language models. Dot. The next sentence was unpredictable, some complex word, and it has split it into many base words. If you notice, this complex word has been split into many base words because the tokenizer was trying to find out the base words from this complicated word. So I hope the concept of tokenization is clear now. You can try this on your own, and that will give you more confidence. Have you ever asked ChatGPT a question and wondered, how does it actually understand what I mean? And how does it know a king is related to a queen and not a dishwasher? Answer is embeddings, and today we are going to learn that. When you give an input to ChatGPT, it divides it into tokens. Every token is given an ID. Then this is passed through a neural network. Based on what are the tokens occurring in the surrounding, every token is converted into a vector. But what is this vector? Let us remove maths and simplify it in symbol words. Think of each vector as a dot. Vectors which have same meaning will be closer to each other, and the vectors which has different meaning will be far from each other. Like king and queen here are very close to each other. Dishwasher vector is far away from this. Now this is very powerful. Why? Because you can do mathematical operations. You can ask ChatGPT what is king minus man plus woman, and it will say queen. Now this is very powerful. By improving the quality of your embedding model, you can improve the quality of your LLM, RAG implementation, and build better applications. Now, since we have these vectors, we need to store it also somewhere, right? And VectorDBs are the place where we store it. But the question is, why do we need VectorDBs to store this? Why can't we store this in MySQL or Postgres or Oracle or any other traditional database? Why do we need specialized databases? Let me explain that with an example. Suppose you have an image of a king. If you store it in traditional database, for example, MySQL, you will store it like this. You store it as a blob. You store some meta information about that image like name, location, size. But what if you want to query this data? Select star from photos where photo is equal to king. You cannot do this on traditional databases. But when you convert this image into a vector, you can query vector database like this. You can say, give me all the photos of the king, and it will give you all the photos because it knows the semantics of that photo. It knows what that photo is about. It understands that photo. That's why for LLMs, we use VectorDBs. Now there are many VectorDBs available. I'm listing few of the famous ones. Pinecone, Faz. Faz is by Facebook, and this is one of my favorite. It's very simple and very easy to use. Then Chroma. Chroma is also very popular, especially people who work on LangChain. They use Chroma. Bilvus, it's also very famous. PG Vector is by Postgres, and it is also very famous. So if I ask you what is this, you'll say it is a boat, even though you have not seen this boat ever in your life. Of course, you have seen similar boats many times in your life, and that's how you know it. Imagine if we have to teach it to AI. The technique which is used to teach AI about these things is called supervised learning. In simple words, we give a lot of examples to AI models. By seeing those examples, they learn. In N-short prompting, that's what exactly we do. If we want LLMs to behave in a certain way, or if you want to teach them something, we can give them examples. And this technique is called N-short prompting. Now, there are three types of short prompting: 0, 1, and few short prompting. Think of short as an example. When I say 0 short prompting, it means I don't give any example
to LLM. And if I ask LLM a question, it gives the answer based on its own current understanding. In one-shot prompting, I give one example to LLM and ask it a question. LLM learns from that example and gives me the answer. In few-shot prompting, instead of one example, I give few examples to it, 5, 10, generally 5 to 7 is sufficient. And based on that, LLM refines the answer it was earlier giving to me and gives me a better answer. Let us see this with an example. So I have a lot of customer support messages. I want to categorize them into 3 categories: login issue, payment issue, and account update. Let us take help of ChatGPT to do this. You can see that ChatGPT gave me wrong categorization. This message should be payment issue, but ChatGPT says it's a login issue. Let us try with one-shot prompting. So the example is different, so I got the wrong answer again. Let us change the example and try again. This time it has categorized it right. Now let us try few shot prompting. Let us try with this. This time I'm getting right answer. So it's very simple. You can tune the LLMs to behave in a certain way as per your requirement by giving example to it. If you don't give any example and directly ask a question, it's called zero shot prompting. If you give it one example, it's called one shot prompting. And if you give multiple examples, it's called few shot prompting. You can always give hundreds of examples, but that is supposed to be overkilling the LLM. It is better to restrict the number of examples to 10 to 20 max. Let us understand what is context window, and then we'll focus on what is context window length. To explain this concept, let me start by saying LLMs don't have memory. Now this will be very surprising for you because you will say that Harjeet, I have chatted with ChatGPT. It remembers all the things that we have been discussing and gives me a very good answer based on history. Let us see this with an example. Let us first install Google Generative AI library. Then we'll import the library. Then we'll load our Gemini API key. We will configure GenAI library to use the Gemini API key. Now we'll initiate the model that we want to use. We want to use Google Gemini 2.5 Flash. Here I'm sending a prompt to Gemini. I'm asking it to remember a number 998877 and don't forget it. I get a response from Gemini that it will remember the secret number 998877. Now, if I try to run it again, here in the prompt, I ask the secret number again, which I gave it in the previous cell. And it says that it doesn't know that number because I didn't tell it. This proves that LLMs doesn't have any memory. They don't have a memory. Every call to LLM is a fresh call, and they don't remember what we have asked it earlier. Now the question is, how does the ChatGPT remember all the chat that we had, uses that as a context, if it doesn't have any memory? Answer is, it uses a working memory. So whatever you chat and whatever you discuss with ChatGPT, it keeps storing that into a working memory, which is called context window. Now this context window is sent as an additional input to LLM as part of every message that you send to LLM. LLM uses history in the context window to build context and create a better answer for you. Now assume that working memory gets full. Then ChatGPT will start to delete the earlier messages, or it will start to forget few things which we have discussed in the past. And at that time, it will start to have a lot of problems. Problems like it will start losing the context of our discussion. It will start giving very stupid answers. It will start hallucinating. Now, the next question is, what is the usual size of this context window? So depending on the model that you're using, the size of context window changes. These days, the models have matured so much that they have huge context window. For example, some of the models have 128K size of context window. And remember, everything is measured in tokens. When I said 128K size, it means 128K tokens. Now that's a very big number. 128K is a very big number. For normal chat that we do with ChatGPT, it is fine. But as soon as you start to use big documents, or in your organization, if you try to use whole of Confluence, everything which is on Git, all the repositories in the Git, then this context window 128K is very less. In that scenario, LLMs will delete a lot of information. It will not have the full context and it will start hallucinating and start giving you bad answers. Now, this is a blessing for humanity, in my opinion. Usually, a lot of people ask this question, is AI going to replace humans? The places where huge context is required, it's very difficult for AI to match the human intelligence because we can handle huge amount of context, which as of now, GenAI cannot. Think about a huge old legacy project in your company that may have huge number of files. Imagine GenAI forgetting some important parts of it and hallucinating and creating a mess of the code. That will be a very bad situation. Now you can ask me that, Harjeet, context window sizes can be increased. See, the context window working memory can be increased for LLMs. But the problem is, bigger are the number of tokens in the context window, bigger is the size of context window, more compute is also required to process these things. And with this, LLMs will keep on becoming more slower. And there are a lot of other problems also, which will start with this. So it is very compute intensive and resource intensive and very costly to have bigger context window, at least as of now. I also wanted to add that when working memory gets filled, when context window gets exhausted, it creates more easy options for cyber criminals to attack your system. So they use something called lost in the middle methodology. They will make sure that the context window is full and they will start giving very long prompts as input. LLM tries very hard at that time to reduce the amount of information and forget some information. And in that situation, sometime they start to ignore guardrails and the safety measures which are implemented in the LLM. And they will start to reveal very key information and try to do some stupid things, which cyber criminals can use to hack the system and damage the system.
So we had seen that LLMs are stateless. They don't have memory. Every request that is sent to LLM, that is treated as separate. But what if you want LLM to remember the context, remember the history and all that? And it is already being done in chat applications, right? So in this example, I'll show you how is that implemented. It's very simple, but very clean way of implementing it. Let us see this example first. Let us install few libraries, then import statements. Then we'll set up Gemini API key. We'll set up the model that we want to use. Then we'll tell our model a secret number. Till now, I have not done any changes to our previous example. So this is just a recap for you. Then I ask that number. It doesn't give me that number. It says it doesn't remember that. Now let us add some memory to this. Adding memory is very easy. So when I start the model, I say model.startChat. I pass an empty list in the history. Now my model will use this list to maintain the history. Any chat which is happening between us, it will keep on storing it in this list. Let us run this. Now I will pass the same prompt and ask it to remember a number 998877. So I've sent this number, remember this secret number. Gemini says okay. Let me ask this number again. And yes, this time it remembers that secret number. So we have added a capability to remember the history to Gemini. We can also print all of the history. And you'll see all the messages here. So this is very simple and clean. History is like our context window that we're maintaining here.
Let us start by setting up Google Colab. That will be our development IDE. In your browser, just search Google Colab. Just click on the first link. It will take you to the home page where there will be a simple tutorial. First of all, we'll do sign in. Fill in your Google account details to sign in. Once you have signed in, it will show you a screen like this. Create a new notebook. Press on connect here. It will take few seconds for the runtime to start. Once it is start, it is ready to use. You can just check it like this. Awesome. Our Google Colab environment is ready to use. Now we will set up OpenAI developer account. Just type platform OpenAI. It will show you the link. Just click on that. On the right top corner, click on sign up if you're logging in for first time, or log in if you have logged in earlier, if you're already signed up. It will give you options to log in via Google or other means. Once you have logged in, you need to create a API key. For this, you can go in the settings section. First, we'll create a project. Click here and click on the create option here. A new project will be created. Now go to API keys. Click on create new secret key. Give it a name. Select the project and create secret key. Once the key is created, click on the copy button and it will be copied. Store it somewhere because you will not be able to copy the key again. Best way to store keys is Google Colab. You can open Google Colab and you will see a key option. Once you click on that, a window will open and you can add the new key. I already have a lot of keys stored here. Open AI API key. I'll just save it here, and that's all. I can provide access to this key to my notebook by switching on this toggle button. And then this is how I can access it. I'll just copy this code, paste it here, and I'll just mention the API key. First time it will ask you to grant access. Awesome, we got the key. Similarly, we can go to Google AI Studio also and get the Gemini key. I was already logged in, so it didn't ask me for login again. But if you're not logged in, it'll ask you for login. So once you are at the dashboard, you can press here, Get API Key, bottom left corner. It will take you to this page. Then click on right top corner, Create API Key. Give your key any name. If there is no project, it will ask you to create project. You can say first project or give any meaningful name. Awesome. So it has created the project. Now we can create the key. So you can just click copy button and copy the key. Then similarly, you can save it in the Collab. For Gemini, Collab has internal integration and it gives you option to directly import the keys. It has automatically added Gemini key. Like we have set up and got the API key for other systems, we also need to get it for weights and biases. This is one library which is going to help us when we fine tune our models. This will help us visualize how accuracy of our model is increasing and how the error is decreasing. So you should sign up and get an API key for this. Last but not the least, you should log into Hugging Face. Hugging Face is like the GitHub of AI world. You will be able to get a lot of models for free. We'll be taking one of the models from here and tuning that model later in the course. You will get a lot of data sets which you can play with and which you can use training data set to optimize your models. Then you can go to spaces and host your applications on Hugging Face for free. Of course, it's free for only certain things, not for all. You have to generate an API key for Hugging Face also. For this, you should click on the icon on the right side, click on access tokens, and then click on create new token on the right top side, and then copy that token and store it in your Google Colab notebook so that you can use it. Today we are going to learn about Retrieval Augmented Generation, RAG. We'll understand what is RAG, why is it required, and how to build a RAG. But before we do that, I want to tell you a story. The story is about Dr. Patrick Lewis. He studied at University College London and he was working at Facebook AI Research. He and his team came up with the concept of RAG and published a paper. But his paper was ignored. It just received around 10 to 12 citations. People said it's a good paper, but not groundbreaking. Fast forward to year 2022. That's when ChatGPT was launched. And it had big problems. It had a problem of hallucinations. If you're not aware what is hallucination, let me explain it with a simple example. Imagine you're interviewing a smart guy. He's giving very good answers. But if you ask a question for which he doesn't know answer, then he guesses the answer or makes up the answer and gives a horrible answer. That's what is hallucination. But what if you tell the guy that whenever he doesn't know the answer, he can Google? Trust me, the quality of answers will improve significantly. And that's what Patrick Lewis suggested in his paper. Now, since the basic concept is clear, let us deep dive on what is RAG. Imagine you have built a large language model. You have used huge amount of data. It is trained only till Jan 2025 data. If you are using that model today, it will not have knowledge of all the events which happened after Jan 2025. For example, if the Ukraine war stops today, it will not have knowledge about that. And these models currently don't know about the data which is inside your organization because that's private data, right? But what if you want to give access to these conference pages to LLM so that a new joiner in your team can ask questions about how to set up the project, what is the logic behind a module? Imagine that will be really powerful. And that's the exact capability RAG brings. Let us talk about how is RAG built. So we start with a lot of documents. We cut them into small pieces. The process is called chunking. If you're not aware of chunking, do watch my full video on chunking. In simple words, chunking is a process of dividing a document into multiple parts. These chunks are then passed through embedding creator. Embedding is a process of converting text to vectors. It makes easier for neural networks to understand it and find out similarity between the words. These vectors are stored in VectorDB. Now there are many options for VectorDB. One is ChromaDB and other one is FAS. Both are quite popular. My favorite one is FAS. It is like Facebook and it's very lightweight. Now, since we have this data ready, we'll see how it gets used. So user comes, he asks a query to large language model. Large language model doesn't know the answer. So it tries to search relevant information. In return, it gets some information, quickly reads that information and builds the context. Once the context is ready, LLM can give a better answer rather than hallucinating.
While LLMs can access internal information of company using VectorDBs, they can also use web search. With web search, they get access to all the events that are happening in the world, and they can give best and latest information in the answer.
So when you search anything on Google and click on AI mode, Google is using a RAG implementation behind the scene. It gets the best link from Google search, and then Gemini understands that as a context and builds a great answer for you. So now we know what is a RAG, why we need a RAG, and how to build a RAG using some libraries. Now, since we know the process of building a RAG, let us try to implement it. We'll use Google Colab to write all this code, and we will use Faz as our VectorDB. We'll take the chunker and embedder from Hugging Face. So as an example, what we'll do, I'll create a document where there is a lot of information about me. We'll chunk that document, we'll create embeddings, and we'll store the embeddings in VectorDB. Then we'll ask LLM some questions about it, and we expect it to give right answers. Let us jump into the code. Let me reconnect and start this notebook. Awesome. We have started. Let me install some libraries. These are Google Generative AI library, OpenAI library, sentence transformer from Hugging Face, and Faz. Faz is our VectorDB. This may take few seconds. Great. Now let us import some libraries. I will set the Gemini key from my key store. Now I will start a Gemini client. I'll get the Hugging Face API key. Now I'll create a document, simple AI textbook.txt, and store some personal information in that. This personal information is, I am Harjeet. I work at blah blah company. I am from Bangalore, India. Amazing. The document is created. This is just a sample document. You can use any other PDF documents and any other sources to build this tag. Of course, if it is PDF document or any other document, you have to use the converter. So I want to keep this example simple for you. So I'm using a text document. Then we read the document. Here I'm calculating that how many chunks should be created in the document. So I'm saying that for every 500 characters, create one chunk. So if the document is very big, it will divide it into 500, 500, 500 characters. And based on that, it will decide how many chunks should be created. Since the document is small, it is saying we'll create only one chunk. Let us import these libraries. Now I'm initializing a sentence transformer. This is our tokenizer. And this is the model it is using. And using this model, I'll also create the embeddings. This is downloading the model. Awesome. Embeddings are created. Now I will index those embeddings using Faz. Now we are done with the first part. We have done the chunking. We have created embeddings and we have indexed them with Faz. Let us ask LLM a question so that it can start using data from our VectorDB. To simplify this, I have created two functions. First function is retrieve chunk. So whatever question you ask, it encodes the question and creates the embeddings for the question. And then it queries the index, Faz index that we created earlier, and gets the relevant chunks matching that question and just prints it and returns it. Then there's another function, get answer. This is the main function which will be called. This function in turns call retrieve chunk. First it calls this function retrieve chunk. Once it has received the chunk, it will create a system prompt. It will tell the LLM that it is using RAG. So whatever information is received from RAG, use that as a context and answer this question. And then we make a call to LLM here. These are the APIs you should be aware now. And whatever answer it gets from the Gemini, it returns that. Let us run this. First we'll run this and then we'll run this. Now I want to ask the question to Gemini, what is my name? It should search in the Faz VectorDB and give me the answer. Awesome. It says, my name is Harjeet. Now, if I change the question, where do you work? It says, I work in blah blah company. So that's what I had mentioned in the document. If I ask, where do you live? It should say, I'm from Bangalore, India. Amazing. So this is very simple implementation of RAG, but it should give you clarity that how to build it. What are the different pieces? What are the different blocks in building RAG? For AI agents to be more useful than chatting toys, it should be able to book your flight tickets. For this, they need access to flight data. They should be able to access and manage your calendar. If you want them to write code, they should be able to access GitHub. And they should also be able to access internet and search about the latest events on internet. MCP makes all these things possible. Let us see how. In today's video, we'll learn about what is MCP, why we need MCP, MCP versus API, why APIs cannot fulfill the need of MCP, and what is MCP architecture. Let us start with these three words: model, context, and protocol. We all know protocol is just standard approach to do something. In this case, model is AI agent or LLM model, and context means to know the application, what it can do, and how you can use it. So MCP provides a standard approach for an AI agent or LLM model to know what application can do and how it can use that application. Think of it in this way. Suppose you are using Gemini and you have built an amazing app and you want Gemini to use this app. So if you have exposed your app through MCP server, then Gemini can know what are the capabilities of this app and how to use this app. And an AI agent based on Gemini can use this app. Not only this, without any additional development, ChatGPT and Claude based AI agents can also use this app. Let us understand the MCP architecture. So if an airline wants AI agents to access its data, it will set up an MCP server and expose its data using MCP server. Similarly, if Outlook or Gmail wants AI agents to access calendars, they will set up MCP server and let AI agents talk to that MCP server. Then there are MCP hosts. Think of MCP host as your chat application. This will have a lot of agents. Agents are kind of workers of your application. Different tasks are assigned to these agents. Then there are different MCP clients. MCP clients are the way with which these agents interact with MCP server. MCP clients know how to talk to an MCP server. So if you ask your application to check the status of a flight, it will assign the task to that agent. Agent will connect to MCP client that it wants to access flight data. MCP client will contact MCP server to fetch the data and give it back to agent so that it can fulfill the task assigned to it. So this is how the MCP architecture and data flow works. Now a very good question will be that I can do all of these things using APIs. Why do I need MCP? Now it is right to say that whatever you can do with MCP, you can do with API also. But MCP is more AI specific way of connecting with different data sources or different services. And of course, it has certain advantages. The biggest advantage is self-discovery. If your service or your tool is behind MCP, AI agent can talk with that MCP server and get to know what are the different functionalities that it provides, how to use them. While if you're exposing these services using API, the user of those APIs will not know how to use these services, what is the signature of those services, but MCP makes it very smooth. Another major problem that it solves is standardization. With a lot of agentic AI libraries like Google's library, TrueAI, AutoGen from Microsoft, LangChain, there was a need to standardize the tools and these services across these frameworks so that there is no duplication of the code, there is no duplication of tools. So MCP has made it possible. So in this video, we learned about what is MCP. It is a standard way for AI agents to talk to the external world. And we also learned what is MCP architecture.
Since we now know about MCP server, let us look at how to implement it. There are two important components for this, MCP server and MCP client. We'll write code for both of them. Now building MCP server is very important because you will realize that companies are adopting MCP server architecture in organization and it's one of their key strategies at this moment. So think of different departments in the company, sales department, finance department. All these departments will expose their data and capabilities using MCP server. Now there will be teams who will write agentic AI solutions which will connect to these MCP servers within the company and will automate and will do a lot of the stuff which is required for the company. So it's a very powerful technique, methodology, and it is important that you understand it and use it properly. Okay, so we will implement a very simple MCP server which will do two basic operations, add and multiply. So the logic of these operations is not important, but it is important to understand that how will you build your own MCP server and how will you write code for client to access this MCP server. So our MCP server will do only two operations, add operation and multiply operation. Our MCP server client will focus on how it will connect to MCP server, access the tools and get the data. Now there are two ways in which MCP client can connect to the server. Let me explain both of them. Now imagine there is a machine which we also call server. Our MCP server will be running on that machine. If our MCP client is also running on that machine, they will talk through a process called stdio. Now what is stdio? So whenever you print any statement within your program, suppose you're writing a Python program, you do a print hello world. The printing happens on stdio. So MCP server and client, if they're running on the same machine, they will use stdio to exchange the messages. They'll be talking to each other by writing messages on stdio. Very cool. But this can happen only if MCP server and client are running on the same machine. What if they are running on the different machine? Let us see that example. So our MCP server will be hosted on a different machine. Our MCP client will be hosted on a different machine. Both will talk to each other using server-side events. In production environment, this is how the things will look normally. I mean to say, your MCP server will be hosted on a different server in your company, or probably in a different company from where you want to get some data. And your MCP client will be running on your server within your company. And this client will contact the MCP server and exchange information using server-side events. AI agent, which has a MCP client, will contact that weather MCP server, get the information and do the processing it wants to do. Now in our code, we look into how to implement both of these approaches. So this is our first example. In this, we will use stdio technique to communicate between MCP server and client. Let me install some libraries first. So here we are installing some libraries first. These are installed. Now few import statements. We are using async IO in this example. What is it? I'll explain in few minutes, so please bear with me. Now, here I'm importing a library called FastMCP. It is a very famous library to build MCP server and client with very few lines of code. You don't need to write a lot of boilerplate code and just need to focus on the actual logic. It makes it very simple. And I love this library. So we are using FastMCP. Here we are creating a MCP server. Then we are implementing two methods, add and multiply, and we are exposing both of these methods as a tool. If you see, I have written @mcp.tool. This is a decorator which tells the MCP server these methods are available for any MCP client to use. As simple as that. Let us run it. Our server code is done. Now let us focus on the client code. Let me first run it. Great. Again, there are a few import statements. First of all, in the run function, I'm running our server. So before client start using the server, since we are using everything in stdio mode, I want to make sure that our server is running before client start using it. So I'm just starting the server. This is the way to start the server. It just runs a command and runs this Python file. Then here is the client code. I create a client session and call it session. Then I initialize it. Then I call the function tool add and pass it the parameters. Then I will get the results and show it here. Again, I call multiply tool, pass it the parameters, and I will show the results here. Cool, we have already run it. So let me run this example and show it to you. Our client is connecting to the server and we have got these results. Awesome. This was very simple. Now there are two more things which I want to explain you. First is why we are using async. So the Python program runs in steps. First line is first step, second line is second step, third line is third step, fourth line is fourth step. So every line is a step in Python, which is okay for normal programs. But when client and server are interacting, client will send a request to server will then wake up, it will do the processing, and then it will send the response back. While the server is doing all these things, client will keep on waiting for the server, and it will appear to you that our program is hung. Rather than doing that, we use async. What async does is, when client send a request to server, rather than waiting for a response back from server, it starts doing the other work. And when server sends the response back, client consumes the results given by server and does the processing of those. So that's why we have used async library here. While building applications on AI, you will very frequently use async way of programming. So it is better to spend some time on it and learn it in more detail, and it's very simple. I'll probably create a separate video on this thing. Second thing I want to talk about is these write file magic functions which I have used here. There is a problem with Google Colab when we try to use MCP in stdio way. So since client and server both talk over stdio, Google Colab doesn't allow that. If I don't create separate file for server and client code and run it from the console, and if I try to run it directly from Google Colab, then Google Colab will block it and will not allow me to do that. So this is one hack from my side to show you this example in Google Colab. If you don't understand that, it's okay, you can ignore that. More important is that you know how to create MCP server and how to create MCP client and how to establish communication between them. If you write the same code in your local environment also, it will work perfectly. Great. Now we'll focus on communicating between MCP server and client using server events. Let us start. First, we'll install few libraries. It may take few seconds. Then few import statements. Then we'll write our server-side code. We'll create a MCP server. MCP is equal to fast MCP. And then we'll create two tools, add and multiply, and decorate them with this decorator mcp.tool. This will tell MCP server that these two functions are available for any MCP client to use. Great. Now I will write a function to run this MCP server. Awesome. Now let us create a thread, and as part of that thread, start this MCP server. Great, the server has started. Now let us focus on the client side of the code. First, we'll have few import statements. I'll apply the async patch for Google Colab. This is our client side function. So I'm creating a client to connect with this MCP server. Our MCP server is hosted at this link. Then I'm creating a session with this MCP server. I'm initializing that session, and then I'm listing all the tools. It should list both add and multiply tools since we have only two tools. Then I'm calling the tool add by passing it few arguments. Then I'm calling the multiply tool and passing it few arguments. Let us run it. Awesome. Now let us run our client and see if it is able to talk to our MCP server. Awesome. It is able to talk to our MCP server, and these are the results it has given us. It has told us that there are two tools to use, add and multiply, and the add result is 30 and multiply result is 25. Awesome, isn't it? Now this is great. Now this was very simple and it's very powerful. You should think how you can expose different data sets in your organization or different capabilities within your organization. Capability to calculate something, capability to show some data, how you can expose all of these things through MCP server, and that will make your organization MCP server architecture compliant, and that will open the way to use MCP server and build huge amount of agentic AI applications.
Let us talk about Agentic AI. Till now, we have only been asking questions to LLM and they have been generating output text to give us the answer. Now, Agentic AI is different from that. In Agentic AI, multiple LLMs will work with each other to achieve a outcome for us. Let us try to understand this with the picture. So we will have a goal. To achieve this goal, multiple tasks has to be completed. Till now, we have one agent, one LLM, which was doing all these tasks, or it was giving us just an answer to our question. In case of Agentic AI, we'll have one goal. It will be divided into multiple tasks, and each task will be assigned to a separate agent, a separate LLM, and they will work with each other to complete that task for us. How is it better from current way? So when we divide the work into multiple tasks, then we assign the task to a specialized agent. It will not be a generic agent which can do multiple things. It will be a special agent designed for that work. During the start of this course, we had talked about assigning persona to LLMs. This is where it comes out very handy. So these agents will acquire a specific persona and they will be doing their work as per that persona. Let us talk a bit more about why these agents are unique. Rather than generating output for chat, they will be focused on achieving a specific goal for you. By the end of execution of all the agents, they will achieve a specific output for you. We'll see this with an example in few minutes. Agents are able to make autonomous decisions. When you're chatting with ChatGPT, usually it is more used to give you information. The decision making is still with you. In case of agentic AI, agents will make the decisions that how they want to execute the work. Is the quality of output good or not? Do they need to refine the output more? So they will have certain level of decision making power and they will be more autonomous. One more thing that will be different about them is agents will interact with each other. They will share information with each other. One agent's output will be input to another agent. So they will work collaboratively to get the goal achieved for you. Let us see this with an example. Let us talk about agentic engineering team. So our goal is to develop a project. There will be multiple agents which will be required to do that. UI engineer, backend engineer, manager, test engineer, product manager. Each of this role will be done by a agent. That's the persona they will acquire. They will work with each other to develop the project. Let me show an example of agentic AI. I will build the agentic AI solution using OpenAI agents library. I'll use a free GPT-4o mini model for this. So here my goal is that I want agents to work and create a YouTube script for me. So I want to publish a video on YouTube. I give agents a topic and agents will work with each other to generate the script of the video. Let us try this. First, let us do some installs. This may take few seconds. Now few import statements. Now we'll set our OpenAI API key. Here I'm using something called Pydantic. When multiple agents are working with each other, they need to exchange data with each other. And if you want to make sure that these agents are exchanging data with each other in a specific format, in a fixed format, that's when you use Pydantic. You can define a class with specific structure and ask the agent to generate the output following the structure of that class. It is a very good way and very popular way to put constraints on the agent to make sure that they are generating the right output and they are following the rules that you are setting for them. Let us import this. Now, this is the output that I want. I have two agents. One is video script creator agent and other is outline builder. So I will give the topic to outline builder. It will come up with the high level outline of the topic. It will hand off, it will give the output to video script creator, and video script creator will use that outline and generate the script, and the format of that script will be in this format. Let us run this. This is the name of the video script creator. This is the model we are using. This agent will be used as a handoff. It will be generating a YouTube video script based on a topic outline. And these are the instructions given to it. Let us run this. And the output type here is video script. This is the object that we create. We are asking this agent to specifically follow class structure to generate the output. Awesome. So this is our outline builder. The definition of the outline builder is also very similar. So earlier I had given handoff description. Here I have mentioned handoffs. I'm saying once you're done, hand off your output to the video script creator, which we have created earlier. Awesome. Now let us run this. The topic that I have given to it is model context protocol in Agentic AI. So I'm running this. It will generate the output. It will take few seconds. Great, output is generated. Let us print it in Markdown script. Awesome. This is the script that it has generated for me. It is saying introduction to Agentic AI. Opening scene should be this. Cut to visuals. Understanding context protocol. How context protocol works in Agentic AI. Applications of context protocol and all. See, the quality of the script may not be great, but what I want to depict here is that how multiple agents can work with each other to achieve the goal that you have set for them. That is amazing to see here. And it's very easy. So you can create multiple agents, create handoffs between them, and it can do a lot of stuff for you. Now, there are many agentic AI frameworks with which you can build your applications. There is OpenAI Agents library, which we just now used to automate script creation for YouTube video. Then we have Microsoft AutoGen, which is good, but I think can be simplified a bit more. Then there is CrewAI. Last year, when I started using Agentic AI, I was amazed by CrewAI. There is almost no learning curve, and the speed with which you can build POCs is really amazing. OpenAI's agentic library, which we just now used, is also very simple. And I must say, when OpenAI started, their agentic AI library was not simple. It was very confusing for some people. But now they have adopted a lot of the concepts which CrewAI brought in, and they have improved OpenAI library. And I must say, OpenAI agents and CrewAI are very similar to each other now. And there is very small learning curve if you want to start building Agentic AI. Then we have LangChain. LangChain is the most popular of all the Agentic AI frameworks. But the feedback that I get from a lot of people is that there's huge learning curve there and it's a bit complicated. I also agree to that, but I feel LangChain is the most mature for production application. But the learning curve is high. Then we have Google's ADK, Agent Development Kit. It is also good, but it's not that popular. And I think the learning curve is also high there. So for learning purposes, I will recommend you to try OpenAI Agents Library. That's best, or CrewAI. You can do a lot of prototyping in very less time, build very good applications with these. On the GitHub repository for this course, I have created demos for all the Agentic AI solutions except Google ADK, and you can use them. There are some good applications that you'll be able to see there. I have created a CrewAI demo of digital engineering team, where we have an engineering lead, backend engineer, software engineer, a test engineer. They do certain tasks and generate the code for us. There's the LangChain demo. There's the AutoGen demo. You can use all of these to learn and build and treat this as templates. to build agentic AI applications for yourself. Building agentic AI applications have become very popular, and people have come up with a lot of design patterns to make sure that these agentic AI applications are giving you the desired result. These design patterns are generic and can be applied at many situations. Now we will discuss those design patterns which you can use to build your applications. I have listed them here and I'll go through each one of them. First one is a React pattern. This is one of the most foundation patterns in agentic AI. So here you force the agent to think before it acts. Sometimes the agents can be very impulsive. They may be in rush to give you the output. In that process, a lot of time they don't follow the steps they should be ideally following and they give you a very undercooked output. When you use this design pattern, you're forcing the agent to follow certain steps to generate the output. So the quality of your output improves. So the flow will be like this. The agent will observe what is the problem that it needs to solve. It will think about the current situation. Then it will call the specific tool. Tool here is a MCP server. It will call the MCP server to get the required data or to get the required output. It will observe that output, analyze that output, and then it will take the next action based on that. This is how visually it looks like. It will think, it will take action, then it will observe, it will analyze the output of that action, and then it will think again and take action again. This process will repeat. Next one is reflection pattern or critique pattern. This pattern is usually used when we are doing coding work or when there is a long output being generated, like long blog post or long writing assignment, long form of writing output. In this pattern, the output of the agent is reviewed by another judge agent and it gives it feedback like line 4 has a bug, your tone of your message is very casual. It will give it some feedback and there will be a loop between these two agents to improve the quality of output. This is how visually it will look like. There will be a draft output generated. A critique agent or judge agent will analyze that and will give the comments. Then it will go through the refinement process. Again, it will be analyzed by the critique or the judge agent. And again, the feedback will be given. This will be done for a certain number of times. And then the final refined output will be generated. Next one is the router or classification agent. This pattern is like a traffic controller pattern. Think about a customer care bot where one request will come from customer. The bot, which is the router agent, will decide this is a sales request or this is a support request or is it a technical request. So it will route it to the right set of agent to help the customer. This is how it will look visually. There'll be a user request. The routing agent will analyze that user request and send it to the right agent to handle that request. It may be a support request, it may be a sales request, or it may be a tech assistant request. Next is planning pattern. In this situation, there will be a planning agent which will analyze the task given to it. It will plan the steps to solve that task, create a checklist, and then it will assign the task to other agents. This is how it will look usually. There will be a goal given to the planner agent. Planner agent will analyze the task. It will list the steps that it needs to execute to achieve that goal. Each of that step will be assigned to another agent and it will monitor the outcome and execution of the whole process. Next one is boss worker pattern. It is very similar to the master slave architecture that we are aware of. So there will be one manager and there will be many workers assigned to that manager. Manager will plan the work and it will delegate the work to the workers. Workers will do that specific task and respond back to the manager with output. Manager will combine that and give the final output to the user. This is how it will look visually. So there will be manager agent which will delegate the work to other agents, and once those agents are done, they will submit back the work to manager who will consolidate everything and give the final result back to the user. Handoff pattern is another pattern. This is kind of assembly line. Whole of work will be divided into steps. Each step will be assigned to an agent. In this case, the work will not happen between agents parallelly. Everything will happen in sequential way. Agent A will do the work, it will pass the output to agent B. Agent B will do the work, it will pass the output to agent C. In this situation, agents cannot run in parallel with each other. In the earlier patterns, in a lot of situations, the agent could run and do the things in parallel. So this is more of a sequential pattern. Next one is group chat design pattern. Assume there is a group chat between the agents. They will talk with each other and solve the problem. So in this situation, each agent is very clear of their role, but the task is common for all the agents. There is no segregation that, okay, this developer will do this task and then it will hand off to other. They work together to achieve the goal. For example, developer agent and tester agent will get into a chat. They will talk about a bug and find out the solution of that bug. in that chat. This chat pattern has become very popular. I have used it with the Microsoft AutoGen. So this is how it visually look like. There will be a shared chat board between all the agents. There will be coding agent, there will be tester agent, reviewer agent, writer agent. They will keep on sharing messages with each other, and they will have a shared goal that will be the topic of discussion, and they will share their opinions with each other and achieve that ultimate goal. Now we are in the most interesting part of our course, which is about fine-tuning a large language model. Before we talk about fine-tuning, it is important to know how large language models are first built. So that's called the pre-training process. During this process, huge amount of data is given to large language models, and large language model build language skills during that. These models learn general knowledge and information from the data that they have been given, and they become good at general tasks. But these models are not good for doing expert tasks which you want it to do. Suppose you have a company and very frequently you launch products. If you have a very specific way of deciding the price of that product, then that is very unique to your organization. Now assume that you want to do that work with the help of large language models. For that, large language model has to be tuned to know the process that you follow to assign a price to that product. It has to see the examples, the model has to be tuned for that process. A general model which you use in outside world will not be able to do that. This is one of the examples where you would like to fine tune the model. So if I have to explain it with an analogy, pre-training is about a kid going to school, learning the general skills, learning maths, science, and general subjects. Fine tuning is a kid going to college and doing specialization. Let us look at more use cases for fine tuning a large language model. One of the use cases of fine tuning is to train a customer support bot. This bot will have knowledge of the processes within your organization, knowledge of the policies of your organization, and it will have the branding awareness and the tone with which it needs to interact with the customer. So for this kind of use case also, you would like to use a fine-tuned model. Code generation. So your organization may have a specific way of writing the code, specific constraints to write the code. If you want to use Agentic AI or if you want to use LLM to generate the code, you may have to fine tune the models for your use case. And if you're trying to build the domain specific models like medical domain LLM or legal domain LLM, then also you may have to fine tune the model by giving it the data about those cases, those legal documents as the training data set. Now, LLMs can be fine tuned in many ways. One of the ways is full fine tuning. It is very powerful technique, but it's a very expensive technique. So LLM is nothing but a very huge neural network. It will have information of connection between the neurons and the weights and all. During the tuning process, we will change these weights and find out which weights give us the best output. Now, imagine you have to change all the billions of weights of one of the model. That will be a very expensive operation. It is not a recommended approach, and it is not possible economically also for organizations to go with this route. Now, other approach which is most widely used one is PEFT, parameter efficient fine tuning. It is group of techniques which is currently very famous to fine tune the models. LoRa and QLoRa are part of it. Let us learn about LoRa. LoRa stands for low rank adapter. In this technique, we first decide the model we want to tune, and that's called the base model. All the weights of the base model are frozen. We don't change anything in the base model. Instead, we come up with a new smaller adapter. You can also call it patch, and that patch gets attached with the base model. Now the weights are only changed for this patch after seeing the training data. And when these both models are combined, base model and patch model are combined, you get the desired effect of this new model becoming expert at the new task. Now this is very fast to tune, and it needs comparatively less resources from the previous process. But why is it called low rank adapter? The smaller patch that we attach to our base model is called the adapter. Now if I have to explain rank is in simple way the size of the model. Every model is just a matrix of numbers, and rank represent what is the size of that metric. Our frozen model is very big. Its rank is huge, and the adapter is of small rank. So we move from a huge ranked matrix to a smaller ranked metric, which acts as an adapter to do this specialized task. So hence the name low rank adapter for this algorithm. Now LoRa has a problem. The problem is that to put a patch on this base model, the base model has to be loaded in the memory. Now, since the base model is very big, it still needs huge amount of RAM to do this fine tuning. Then comes the concept of quantization. So think of quantization as a compression. Suppose you have a 4K image of yourself and you compress it to 1080p image. Yes, the quality of the image has come down slightly, but still image is very useful and it does the job that you want it to do. In very simple words, that's what quantization do. So a model is represented by a matrix, and matrix contains the weights, and these weights are 16-bit usually. What quantization does, instead of storing this weight in 16 bits, it stores the weight in 4 bits. With this, you lose some accuracy on the model, but it's not much. Studies have shown that the quantized model loses very less amount of accuracy, but the gain on reducing the RAM requirement is huge. So that's why for fine tuning, we first quantize the base model. We load it in 4-bit or 8-bit so that the memory footprint is reduced. And then we apply the LoRa algorithm on top of that. And that's called quantized LoRa QLoR. Now we'll talk about different steps of fine tuning the LLM model. We'll do all the fine tuning in Google Colab Notebook. First of all, we'll install some libraries. We'll install TRL library, unsloth library, bits and bytes library, PEFT, and accelerate library. Let me explain what are these. TRL library is from Hugging Face. This library has implementations of SFT trainer, different algorithms which are required to fine-tune the models. Bits and bytes and PEFT library has QLoRa implementation. These libraries are used to load the model and quantize the model. Accelerate library helps us run the PyTorch code on GPUs. So basically, with minimal amount of changes, you can run the PyTorch code on GPUs. Last one is Unsloth library. It has become very popular. This library makes loading the model, training the model more memory efficient and faster. Next, we will select the base model, which we are going to tune. In this case, we will select Google's Gemma model. We can also select Llama model or any other model that you want. The process for fine tuning will stay same. Then we are going to prepare data set for our training. I'm going to use already provided data set from Hugging Face. We are going to add a prompt column in that, and we are going to use that prepared data set for our training. Then we are going to create an object of SFT trainer, which is our main object through which we will train the model. This will need few configurations and hyperparameters. Now hyperparameters are very important. We're going to discuss those in few minutes. Then we'll start our training process. We'll use weights and biases library to observe how our training process is going. It will show different graphs to us that how our training loss is decreasing, is our accuracy increasing or not. All those graphs you can see on weights and biases library. So once our model is trained, we're going to test the model. Now let us discuss the hyperparameters that we're going to use for LLM tuning. First parameter is R. R represents the rank of our smaller matrices, rank of our adapters. It can be 8, it can be 16, or it can be 32. Generally, I have seen it is around 16. If you keep the number very high, then your adapter matrix will be bigger. It will increase the memory requirements and GPU compute. Usually, when I tune the LLMs, I keep it 8 or 16. Next one is LoRa alpha. LoRa alpha decides how much dominant are adapters weight as compared to original model's weight. It decides how fast you want to tune the base model. So once this value is decided at the start of training, this value stays constant throughout the training. Usually the value of LoRa alpha is double of R. When you're using unsloth library, these value of R is usually equal to LoRa alpha value. Next one is learning rate. Learning rate is a dynamic number. Learning rate decides how fast you change your weights when you are close to your minima or when you are far to your minima. Having a higher learning rate can be problematic because you can end up jumping the minima and you can end up missing to optimize your model. If your learning rate is very small, it may take a lot of iterations to reach to the minima. So you have to decide on a appropriate learning rate. Next one is epochs. If you have 1,000 rows in your input data set, then one full pass through your whole data set is called one epoch. If you're taking 5 iterations of your input data set, then it will be 5 epochs. More epochs you run, usually the accuracy of your model will increase. Once there is no change in the accuracy of the model, that is considered as a signal to stop running the training. Next hyperparameter is batch size. Batch size decides after seeing how many rows you are going to update the weights of the model. You can update the model weights after each row, or you can say, I want to take average loss of 4 records and then only want to update the model. So bigger is the batch size, it is better for tuning. Bigger batch size also means that you need more memory and more compute. So in our example, we'll keep this around 1. So let us start with hypertuning. First, we'll connect to our runtime. So you should make sure that your hosted runtime is T4. If it is not, just change the runtime, select the T4 GPU and connect. Okay, so GPU is connected. Let us start installing the libraries. This may take few minutes. So until this runs, let us understand the code. After this, we have few import statements where we are importing torch library, transformers, PEFT, dataset library, TRL library, and Hugging Face Hub. Then we'll import the HF token, Hugging Face token, so that we can download the model there and push the model there. Then we'll log into Hugging Face. This is bits and bytes library. So we want to quantize the model into 4-bit and we want to load it in memory. So here we are setting the configurations. So we are loading the model in 4-bit. We have set it to true. We are using normalized float 4 and our compute will be in float 16 so that it is faster, and we are using double quantization so that we can space maximum amount of RAM. Okay, so we are going to download Gemma 2 billion model, which is not very big but very suitable for our use case. Awesome. So this has also been installed and now our model is being loaded. This may take few seconds, 30-40 seconds. Gemma model is being downloaded and loaded into memory. As you can see, this is the size of the Gemma model, 4.95 GB. Let us understand the code that we're going to run ahead. So Gemma 2B is an instruction model. So we will give it an instruction and it will give an appropriate response. Till now, we have not done any tuning. Let us see what it does. So we have asked it to write Fibonacci series in Python using recursion. I'm sure it will give us right result, but there are some limitations of the result that it has given. Let this part run so that I can show you the output of that. Great. So the code has run. Now our model is trying to generate Fibonacci series code using recursion in Python. So this is going to give us the right answer, but not in right format. Awesome. This has given me the right answer, but I would like it to give me some documentation also as part of this code that it has generated. It should tell that what is this Fibonacci function, what is the input and what is the expected output. There should be some documentation in the code. I don't want to add it in the prompt. I want to make sure that's the default format that it's following. And that's the tuning we are going to do. We are going to tune the model to answer in that way that it always generates the documentation along with the code as a default behavior without making any entry in prompt. So let us download our dataset. Awesome. We'll print some of our dataset. So this is the text it has. This is the instruction, and I'm asking it to give instruction. Now I will add one more column to my dataset, a prompt column, which will enhance my dataset so that I can give it as a training to my model. So this step is enhancing my dataset. It is adding a prompt column. We will train our model on that prompt column so that our model learns that it has to give the output in that format. This also may take few seconds to run. Now let us separate our train and test dataset. This is how our test dataset look like. We'll prepare our model. We'll print the current model. These are the projections it has, QKVO projections. Let us run this. Let us print all these projections. Okay, so we have now listed all the projections. I have saved all these projection names in the modules variable. We are going to pass that modules variable in the LoRa config so that our trainer knows that it has to tune these modules. I'm using R as 8, LoRa alpha as 16. Remember, R is the size of our adapter matrix. If the size is very big, one, you will need a lot of memory. Second, you can also cause a problem of catastrophic forgetting. Sometimes these big matrices overpower the base module. So when the training is done, your base model loses its language skills. It will not know how to make proper sentences, but it will become good at the task that you have taught it. This is called catastrophic forgetting. So while I was preparing for this video, I faced that problem. I'll show you that at the end of this video. Let us run this. Awesome. Now this is our trainer. So we are saying each batch is going to have only one record, and we are going to accumulate the result of 4 batches, then only going to update the weights. This makes sure that while running, we don't run out of memory. If you make it 4, I'm sure your Google Colab will crash. You can try that. Then this is the learning rate. If you make it 5, then the learning rate is very low. Your algorithm will move towards minima very slowly. If you make it 1, E4, it may happen that your algorithm doesn't reach to minima and jumps it while making big steps. This number is usually the standard. Let us run this. So we'll pass this config to our trainer and we'll start the training process. So training process is started. You have to copy the weights and biases libraries API key here. Then it starts. So we are going to run 100 steps. We're going to run 100 steps, and after that, we're going to test our model. Our model has started to get trained. This is the loss. You can see that the loss is decreasing as more and more steps are being run. You can see this in weights and biases live website also. Okay, so this is our training loss, and you can see this is decreasing. This will get updated with every step, and you can see our mean token accuracy increasing with every step. Now after a point, this will get stable, and that's when the training is complete, or maximum number of steps are already done. So we have run 40 steps. So this process will take few minutes. In video, I'm going to shorten this. Looks like our trainer has completed. Yes. So the training process has completed. Let us save our model. Now we'll merge our base model and the new model. In meantime, you can see the usage of RAM, and you can see the RAM usage is increasing. Our GPU RAM is 8.9 GB used, and our system RAM is 11.1 GB used. Great. So our model is saved. It took around 7 minutes to save the model. Now let us run our trained model and see what has changed. This output should contain some documentation along with the Python code. Let us see if we are able to successfully tune the model and change the behavior when it generates output. Awesome. So it has generated a lot of documentation. You can see here, this is the Fibonacci function. It has given an alternate method. Then it has given some explanation. Cool. So it is giving us more information. I hope this was very useful. You can also tune models as per your requirement now.